To turn on the Instron, the on-off button is way at the back. And you'll hear it whir and start to turn on as the power comes on to the panel. Now we're going to go turn on the computer. Okay, I'm going to attempt to show you how to load this specimen into these heads. Because I have hit the return button and that this is the home position from which the test will begin, I want to make sure that there's enough room so that the grips can actually grip onto the specimen. You want more than an inch, and it can't be so big that it's hitting the platinums at the top. So the way we do this is these grips are controlled. Hold the bottom one open, and you'll do the top one first. Before you tighten it down much, you need to make sure the specimen needs to be centered and vertical. So you can see here that it's probably not quite vertical. I've got it much farther forward than backward. So I'm going to want to open the jaws up and move it backwards. And then I also need to check front to back. So I want to make sure that it's both in the center of the grips, but also that it's vertical in both axes. I think I have it. Okay, now I have not tightened it down. So what I'm going to do for tightening is I want to use my hands, and I'm going to give it one good tug. Okay, so now it's tight, so it should be gripped well, but not so tight that we create a stress riser here. If it breaks near the grips, we know that we have damaged the specimen so that it was significantly less strong at the grips than in the middle. The goal is to get it to break somewhere in the middle. Okay. After I have completed the positioning of this one, I will want to then do the bottom. So at this point, I check it, I have it pretty vertical front and back, as well as in the centers. Now I need to make sure that I go back to my station, and you can see that it has actually placed some load on it. And so I'm going to go ahead and balance the load. Make sure it's returned to the location that it's supposed to be, and then balance the load. And then I'm ready to do my test. Please don't forget to add the shield. We have plexiglass shields that we want you to place so that we're all protected. I'm going to go ahead and show you how to run a test. First of all, you will hit the test button, and then you choose the test that you're running. I have a rectangular section, and it's a tension test, so I'll choose the 314 rectangular tension test. I'll hit next. It's going to open a new file, and I need to name it something that you can find later. So I'll put my last name, and you'll probably want to tell yourself what this is. So this is a low carbon steel rectangular tension test. Okay, now it's going to ask you for those dimensions that you recorded earlier. So you need a width and a thickness and a length. Next, and we will see when I hit start. Now we're going to see the specimen data being recorded here on a chart. I hit go, and it's recording it. At this point, this test should take not more than 5 minutes, and we'll go ahead and watch it, and we will use this data after we're done. The graph is starting to bend over, That means we're getting close. Hopefully you'll be able to see as the fracture happens. The load is actually starting to go down as we continue to lengthen the specimen, and you'll be able to start to see a little bit of necking down. I'm a little concerned that it might be happening up at the top grip. Yeah, I'm pretty sure it's happening up there at the top grip. You can see it necking down, and it's going to break here very soon. And that's the end. The load is dropped off of the load displacement data, and I will open up and take out the bottom piece to show in fact that yes, it was the top piece that broke. The bottom piece did not. I'll go ahead and loosen this, and it's stuck to the jaws, and so I will use something to encourage it to come off. You'll want to inspect the piece after you're done. You'll see that there are claw grips. And one thing we notice with this one is that the claw grips they're not scratched and pulled through the surface of the steel. And that's a good, we had it tight enough. If it's not tight enough, then there will be scratch marks in it. And then secondly, we see the end piece and what kind of fracture plane that was. It did neck down in both directions, and you'll be able to get up very close to the surface and inspect. This is actually a cup cone failure because this top part had kind of a cup, a concave surface, where the bottom, let's see if I can find it, there it is, and show you. Well, this one looks very flat. Once you piece it together perfectly, if you knew where your initial start and stop points were for your gauge length, you could measure the final gauge length off of this. Now that takes into account the recoil. At this point, you're going to want to reset your equipment back to the gauge length. We will reset the load here in a minute, and we will go ahead and do another test, because we know that one specimen is not enough of a test. You have to have 3. Click on the next, enter the values before the next one is, and so you will have cut yourself another one, put the values in here, and test it again. This will capture all of that information, okay? Once you've completed 3 tests, we're gonna go ahead and finish, save it as, and it will create a folder for you. But I want you to put it in the right folder. There was a folder up on the desktop that I made that is 314 Fall 2020. And then once I'm done here, I can go ahead and close out. Finish the sample. After you've done 3 samples and then you get to this point, you're done. So we will exit out of here. And now here under Engineering 314, right, there is a file that's called Kirkvold. And actually there's 4 files. They are a file folder, an ID_10s file, an IS_10s file, and an Adobe Acrobat file. If I open the Acrobat file, it'll show a plot of my data. What you want is inside the folder. It's specimen raw data. Okay? Save those to your thumb drive so you can take it with you. This is not connected to the internet. All right? When you're done, clean up your station. You'll want to photograph your tested specimens and make sure all your data is complete before you go ahead and shut it down.